Okay, so let's see if we can finish up this review. That is not the review guide. Hold on.
Yeah, let's do that.
All right, if only we were doing math 7. Let's see here. Algebra 2, chapter 1, review guide, test review guide. Where did we leave off? All right, so we made it through. Oh, that's right. We did the second literal equation. So now we're doing the third. Okay. Hopefully this is all working as intended. Okay, so for C, we have S. Let's see if I can do this. S equals, nope, just gonna be like that. S equals pi r squared plus pi r h, and we're solving for h, so we've got to isolate the variable h. So what would we do first? Right, it's reverse order of operation. So instead of getting rid of that xr that's being multiplied times h, we need to get rid of the addition. So we're going to subtract pi r squared from both sides. And when we do that, we end up with s minus pi r squared equals pi r times h. So now what's our last step? What are we dividing by? Pi r. Yep. That gets rid of this. It does isolate our variable h. Now you have to be careful with this. We could have factored out a pi r, but it still would not have really helped isolate h. So it was unnecessary. So we just do our subtraction and then do our division. And we end up with variable h is equal to s minus pi times r squared divided by pi r. We cannot simplify anymore because that pi r cannot be canceled out from the minus pi r because it doesn't exist with the s either. When things are separated by addition and subtraction, you cannot reduce terms unless you can factor out the same terms from what's being added and subtracted. So this is as far as this one goes. Do we have an exclusion that we need to state? So what is pi? We know pi is 3.14. That actually has its own, that's a constant, even though it is a symbol. But yes, but you're absolutely right. So this is our literal equation solved for h, but it will only work if r does not equal 0, because we cannot divide by 0, and that's in our denominator. Okay. And actually, I did get lucky looking through the homework. Some of these, like these, I think were C problems for this section 1.4, but they do relate directly to what you're going to see on the test. And I had a few of those. All right, so let's move on to section 1.5 was, okay, yeah. Just let me see them so I can confirm that.
Oh, so yeah.
Yeah, you know. All right, so section 1.5 is actually applying. Oh, lovely. Here. All right. See hundreds. How many milligrams they are?
800.
They are 800?
Yeah, I'm only gonna take one.
Okay.
Just so for your sake.
Thank you. I was gonna say, those are I8s. That should help. Okay, so this is the section where we had all the word problems that apply to the equations that we learned about in section 1.4. So this first one is our distance equation. So what is the distance equation? Right, so distance equals rate times time. This is not the absolute value distance that we work about with later. Okay, so for this one, 2 airplanes leave at the same time from airports that are 880 miles apart. So I am gonna go ahead and I'm not gonna do the whole table thing. But I am going to do the diagram. So we have airport 1, airport 2. What's the total distance? Right, 880 miles gets us from airport 1 to airport 2. Now, 2 airplanes leave each of these airports. So I've got, I'm gonna change colors, I can't do it. I've got one coming from this airport and one coming from this airport, and they're both headed towards each other, traveling towards each other. If one plane travels 126 miles per hour slower than the other, and they pass each other in 2 hours, how fast is each plane traveling? All right, so the slower plane is going to travel the farthest distance. Think about this logically, right? The slowest plane is going to travel, the shortest distance because it's going slower. The other one is going to travel faster before they meet. So I'm just going to say this is, actually I can close you, I think. Give me just a second. Don't save. Where is my, there we go. All right, so this is distance 1. Going this way, and this one is distance 2. So what the distance equation, in this case, the distance for the 2 planes is not the same because one's going faster than the other, but they're traveling in the same amount of time. So obviously, if they're both traveling for 2 hours, the one going slower is going to have a shorter distance. But we do know that the distance that one plane traveled plus the distance of the other plane equals our total distance. And we can use that to find their rate of travel. We've also given their rate, their speed, in terms of each other. So we can solve for an unknown variable. All right, so we've got our distance equals rate times time. So let's do it as a list. We know that our total distance is what? I'm sorry, I'm trying to do this without putting my hand on it, and it's awful. Okay. We know that the total distance equals 880 miles. All right, so what about the first plane? In this case, our distance 1. So we have a rate for the first plane and a time for the first plane. So in this case, this is the plane that was traveling faster. So do you want the fast plane to be our X? Okay, so we'll make so we're gonna solve for the faster speed, the speed of the plane that's going faster. Okay, and what's its time? 2 hours. Okay, what about now the rate and time of the second plane? So we know the time is the same, it's still 2 hours. What about its rate? There we go. It's the speed of the faster plane minus what they've told us, which is that it's traveling 126 miles per hour slower. All right, so that gives us our total distance. And then of course, D equals rate times time. So we know that the rate and time, the product of the rate and time of the first one plus the product of the rate and time of the second one gives us our total distance. So we can now put it together. So we know that distance 1 plus the distance of the second plane equals the total distance. And now we just plug it in. So distance 1 is the rate. I'm actually going to put time first because that's my constant, 2x. And distance 2 is also the 2 hours, but it's times x minus 126. And then my total distance is 880 miles. So is everybody clear on where that came from? This one is distance 1. This one is distance 2 based on my formula. All right, so what do I need to do first? I got to distribute first. So that's 2 times x and 2 times negative 126. So I end up with 2x plus 2x minus 252, I think, equals 880. Yep. All right, now we combine like terms. 2x plus 2x is 4x. And I'm also going to go ahead and add 252. Space here. So this is 4x equals 1,132. I think 13, carry my 1, 11. Yep. All right, and we know that 4 is going to divide evenly into 1,132 because it divides evenly into 32. So x equals 283 miles per hour. All right, so what did we just calculate? Which plane? This is the faster plane. So what do we have to do? Right, so that's our faster plane. The next one is x minus 126. So this is 283 minus 126. And that gives us a speed of 157 miles per hour. So this is rate 1, or faster plane, and this one is rate 2. All right. Next one, how much pure water must be added to 300 milliliters of a 3% sorbic acid solution to make a contact lens solution that contains 0.1% sorbic acid? Okay, so in this case, what are we doing? We have 300 milliliters of a 3% acid, and we need to create a 0.1% acid solution. So we're diluting it. Yes, we're watering it down. So we're going to have a lot of solution when we're done, because from 3% to less than a percent, to 0.1% is a huge difference. So we're probably going to have to add a lot of water. So the way I'm going to do this, again, slightly different than the way we do it before. I'm not going to use the table. Instead, in this case, I'm going to sort of draw. Y'all can do whatever you want. I mean, I'm going to, let's see, this is a small one. I'm going to have my 300 milliliters of 3% solution. So that's my little beaker. 300 milliliters. And I need to add some unknown amount of pure water. So that's my X milliliters. Now, how much acid is in the water? No, that's what's in our solution, right? We're adding pure water. What's pure water? 0%. And what's anything times 0? Right, it's 0. So we're adding 0. So we can sort of eliminate that when we get to our problem, but I'll show you what I'm talking about in a second. All right, and then we're going to add these two together, and that's going to give us our final solution. Me and my fabulous artistic skills, which needs to be at a 0.1%. And we know that this, how much of this final solution are we going to have? 300 plus X. Thank you, Matt. Perfect. Right, that's the total volume, 300 plus X milliliters. that we're gonna have in our final solution. Now, if we had a 0.1 solution, well, 0.1% solution, and we were creating a 3% solution, instead of diluting, what would we have to do? Where did those come from?
There's the office. There's lots.
Okay. All right, if we're going from a 0.1 solution to a 3%, we would evaporate the water. So we would be taking away pure water to get a higher percent solution of acid. In this case, we're diluting it. So that's our equals. 3%, 300 milliliters of 3% plus X milliliters of 0% needs to give us 0.1%. So I was hoping that maybe the visual of this might make more sense than just the table, because this is essentially what we've done. And so what we have to find out is, what is that X? Now, we know that 3%, so what's 3% as a decimal? 0.03. Careful, 0.3 is 30%. So 0.3 times how many milliliters? 300 plus 0%, which is 0.0 times X. And what's anything times 0? 0. So eventually we'll eliminate that, but I'm going to put it so you know where that went. Equals our final, which is 0. So how would we write 0.1% as a decimal? .1, it is 0.1%. So how do we write that as a decimal? Yes, put the 1 in the right now it's in the tenths place. We need to put it in the thousandths place. So 0. It's tiny, 0.001 times 300 plus X. Okay. So there's our equation. What do you want to do? You want to get rid of the decimals? We really need to get rid of the decimals. All right. The good news is that this is essentially just 0.03 times 300 equals 0.001 times 300 plus X. So now we can solve for X. But we've got to multiply the whole thing.
Yeah,
Ooh.
you're just gonna be multiplying by 300. You're just gonna get.
Eventually you'll still have a decimal. So you want to do it without?
Yeah.
Okay, we can do that. Because if we did need to reduce, if we need to get rid of our decimals, what would we need to multiply both sides by? 1,000, because of that 0.001. That 1 is it. So if you look at your lowest decimal, in this case, it's in the thousandths place, that place value tells you what you need to multiply by. Because that 1 is in the thousandths place, we have to multiply both sides by 1,000. Okay, so y'all are gonna be mad that you made this decision. That's okay. Go ahead. Okay. Okay, so what's 0.03 times 300? Okay, so 9. Well, these 2 zeros move your decimal back 2 places, and so you end up with 3 times 3, which is 9, equals what's 0.001 times 300? Those 2 zeros move it 2 places, so we end up back to 0.1, no, 1 times 3, 0.3 plus 0.001x. Now, do you want to get rid of your decimals? So you're not dividing, so you're not having to divide by 0.001?
They're not like. Oh.
Well, we can, okay, so we can, let's just keep going. What do I need to do? I need to subtract 0.3 by both, on both sides. Nope, 0.3. So that gives me 8.7 equals 0.001x. Yes, you don't need calculators. When you do, okay, so 0.001, is that a super tiny number? So do you think a super tiny number is going to go into 8.7 many, many times? Okay, so when you, yeah, just how many times do we have to move the decimal to get that decimal, to get that denominator to 1? It's 3. Yeah, sort of. Okay, so how many times did I move that decimal? 1, 2, 3. So move your numerator's decimal 3 times. What do you end up with? One, two, three. 8,700 milliliters of pure water is needed. Now, if you'd multiplied both sides by 1,000, you would not be dealing with the decimals, but as long as you're comfortable subtracting with decimals, you should be fine. Yep. So, it's 8,700 milliliters of pure water will give you a 0.1% solution. Okay. That's it for section 1.5. Yeah, this is the board one. It's really not, but I do want y'all, I want y'all to follow me closely on this one, okay? When you cannot get rid of the fraction inside the parentheses at the same time that you get rid of the fractions outside the parentheses. Because it's different. When you multiply, when you try to get rid of those, that 3 and that 4, you can't really touch that 6 just yet. So be careful when you've got a parentheses. And again, this one is actually, the one we just did was number 31 from section 1.5. This one is number 40 from section 1.6. So this is one of the exercise C problems. But because I think we do prefer we will eventually get rid of our fractions for the most part. So first, you must, to get rid of your fractions, what is our what is our least common multiple for the 3 and the 4? 12. So what you're going to do is you're going to multiply, and y'all have got to take your baby steps with this one because there were a lot of mistakes in eliminating fractions on the last quiz. So we're getting better, but we're not quite there yet. So if you want, you can even make it 12 plus 12 over 1, whatever, times 2/3 x minus 7 times 12, because we got anything separated by a addition or subtraction that's not inside parentheses needs to be multiplied times 12. This one is the 3, so 12 over 1 times 3/4 minus 12 times 2 times 5, 6x plus 7. Leave that one alone for now. So just so y'all see, I've multiplied every term, every separate term times 12. Mm-hmm. Yep. Okay, so when that happens, for the 12 times 2/3, we get rid of the 3, but 3 goes into 12 how many times? So we're left with a 4. So this is 4 times 2x, which is 8x, minus 7 times 12, which is 84, which is less than or equal to. We get rid of the 4. What's left? 3, and 3 times 3 is 9, minus 24 times 5 6x plus 7. All right, so the left side of our inequality is done. It's as simple as it's going to get. The right side, we need to continue to simplify. So you need to distribute that 24 into the 5 6x plus 7. So this is a 9. Now, can we get rid of the 6 when we multiply 5 6 times 24? Yeah, what's left? 6 goes into 24 how many times? 4 times. And 4 times 5 is what? So that's our 20x. Now, we also do have to distribute that 24 into the 7. So 7 times 2 is 140 plus 28. So 140, no, 168. Yeah, 168. And we understand why those are negative now, right? Right, you're distributing a negative 24. Because the 7 does not have a denominator of 6. So what I just did there is 24 divided into, 24 divided into 5 6x plus 7. I'm distributing that 24 into both. Now, 5 6, is that less than 1? Yes, this is a proper fraction. Proper fraction means less than 1. So 24 times 1 is 24. 24 times 7 is a big number. So you know that if you multiply 24 times a number smaller than 1, you're going to get a number smaller than 24. In fact, we got 20. Like, y'all see the logic of that? So 24 times 5 6, you're multiplying 24 by a number smaller than 1. And so your answer has to be smaller than 1, which it is, it's 20. But 24 times 7 is a big number. So that's why you're getting to 168. Because it's 24 plus 24 7 times. Okay, so good. Okay.
So,
Mm-hmm.
send it back,
No.
like, listen,
Mm-hmm.
and like, have the
Mm-hmm.
word so.
No. No. We had some issues there because people were putting in 2/3 as a decimal and making it 0.6, and 2/3 is not 0.6. It's 0.6 repeating forever, which gives you a very different number than 0.6. Don't turn them into decimals. No, it's not. We can do tutoring then. Because at this point, we have no fractions and we have no decimals. So yeah, there is a fraction in the answer. So we can combine like terms now. We have this side stays the same. 8x minus 84 is less than or equal to. We have 9 and we have negative 168. So we end up with negative 20x minus 159. And there's our most simplified inequality. So now we can solve for our variable. We will add 20x to both sides and add 84 to both sides. On this side, we end up with 28x, which is less than or equal to negative, let's see, 9 take away 4 is 5, 15 take away 8 is 7. So negative 75. And then for our last step, we divide both sides by 28 and we leave it there. X is less than or equal to negative 75 over 28. Done. You don't have to figure out what that is as a decimal. But also, do you know that 75 over 28 is going to be probably greater than 2? Uh-huh.
How did that 168 become?
I combined the 9. I had
Oh, it's a positive nine.
yep, I had like terms. And so, yeah, it's positive 9 minus 168. So my answer is negative, but I'm also subtracting because they're unlike signs.
Right.
Yeah, so that's where that 159 came from. Okay. B? We good? Does everybody have this?
Better resharpen my
Meh.
pencil, right?
Ah, you're gonna need 2 pencils. Just grab another one since I'm recording, please. All right, so for B, what do we need to do first? Distribute. What are we distributing? What? Negative 12. All right, and on the other side, positive 2. Easy enough. Okay, so 3D, what's negative 12 times D? That's for negative 12D. And then negative 12 times negative 9. Don't do like I did. Somehow when I first did this, I calculated 12 times 9 is 84. It's not. So that's 108, and it's positive because negative times negative. Minus 28 is greater than 2D plus 6 plus 7. So next step, combine like terms. We can combine 3D plus 12D, and we can combine 108 minus 28, and we can combine the 6 and 7. When we do that, we end up with negative 9D plus 80, which is greater than 2D plus 13. And now we just combine like terms. I'm gonna go ahead, because this is an inequality, I'm gonna go ahead and keep my variable on the left, even though I'm gonna have to divide by negatives. I'm gonna subtract 80 from both sides. Negative 9D minus 2D is negative 11D. We add them because they're like signs, but we carry the sign. These cancel. 80, these are unlike, but my answer is going to be negative. So 80 minus 13 is 67. And then our last step, we divide by negative 11, which means we do what? We flip our inequality, and we have a negative divided by a negative, which is 67 over 11. So that makes it positive. No, just leave it as a fraction. It's not improper. It just means it's greater than 1. I truly despise the whole idea of the proper versus improper. It's not. It's just because the numerator is larger, you know that the value is greater than 1. All right. So for number 2, pretty sure that what we just did will be the hardest thing we did. But for number 2, you need to, I think on the test, it's going to be one of those where you need to write an inequality and solve. I forgot to write that on here. All right, the football team has raised $1,000 to help buy new jersey for the varsity team. If the jerseys are $56 each and a 6% sales tax must be added, what is the maximum number of jerseys they can buy? So we know that this is the idea of cost. So price times tax times the number of items equals our cost. And our cost needs to be what? Compared to $1,000. Sorry, go ahead, what? Zoom in a little bit. Okay. So price times, I'm just gonna raise dots. Price times tax times the number of items equals your total expense, your total cost. So our cost needs to be what compared to $1,000? Less than or equal to. Okay. So what's the price of the items? So $56 times, now here's the thing, if you multiply it times the tax, you're only going to calculate the tax, right? Because think about it, 56 times 6% is a very small number. So you would need to make sure you write this as 1. What's the decimal version of 6%? So 1.06. Because that includes, so the price of the item is 56 and 56 times 1 is 56. So this way we're not calculating just the tax. If we do, what's 56 times 0.06? It's like a couple bucks. So we're adding the 1 so that we can include the actual price of the item. Because technically this is the cost of the item, or I'll say retail price, plus tax. Because that's like 1 plus 0.06. So then you would have to calculate the price of the items, then calculate the price of the tax, then add those two together, and that would be. So it would be a lot more steps. Just make sure when you're multiplying something times tax, you want the cost of the item plus the cost of the tax, and that's what the 1.06 does. And then the number of items is what we're trying to figure out. So that's our X. And that total needs to be less than or equal to $1,000. So I'm just doing the multiplication. 56 times 1.06 is 59.36. So you could do the price of one item plus tax, which is what I just did. That's the 56 times 1.06. So each jersey with tax costed $59.36 times the number of items needs to be less than 1,000. So our last step is we divide both sides by the cost of one jersey. And we get that the number of jerseys that we can buy is like more than 16.84. So what's the maximum number of jerseys we can buy? 16. Because we can't buy 0.8 of a jersey and we can't afford 17. So the answer would be 16 jerseys. All right, these last few are the same that you just did on quizzes. So hopefully it's all still pretty fresh. Section 1.7 is just covering your inequality, like your compound inequalities. So this first one, is this a conjunction or a disjunction? It's a conjunction because 5x plus 9 must be greater than -6 and less than or equal to 16. So we can go ahead and solve this as is, like just leave it together because we're gonna have to solve it and graph it. So what do we need to do first? Nah, we can keep it together because it's a conjunction. Huh? Subtract 9? Subtract 9 from all parts. And we end up with what? Negative 15 is less than 5x, which is less than or equal to 7. Better but wrong. All right, so last step. Yep, divide all parts by 5. And we end up with negative 3 less than, x is greater than negative 3, but less than or equal to 7/5. I made this one up and I made a mistake. I was thinking that they would give us whole numbers. I feel like when we do this on the test probably has whole numbers. All right, so first, because this is a conjunction, there is a possibility that we have no solution or a null set. So we have to graph each. So x is greater than negative 3 means that we have an open circle at negative 3 and a line that runs up the number line. It's got to be larger than negative 3. Where x is less than or equal to 7/5, we know that 7/5 is 1 2/5, which is close to 1.5. So we're going to have a graph somewhere, probably somewhere around here, a little less than 1.5. And x is less than. Is that right? Because x is greater than, this is negative 3 is less. So if you need to write it as 2, you would write it as x is greater than negative 3 and x is less than or equal to 7/5. So yeah, that's why we're going up the number line. You're right. So that one's going to go to the right. That one's going to go to the left. So do we have a solution set that is true for both of these? Yes. Where does it start? At negative 3, open circle, doesn't include negative 3, and it stops somewhere around 1.5, little less than 1.5. And so remember, this graph is our solution set. The stuff above it is just telling us, is helping us actually graph our solution set. If you give me the stuff on top, you have not answered the question. Okay. All right, we'll pick up on this one, the next one tomorrow. And finish the review guide tomorrow.